How's it going, everyone? In this video, we're going to show the proof of the Pythagorean theorem. So it's not just something you have to believe, you actually see why the theorem is in fact true, that it cannot be any other way. Now there's many different proofs. What we're going to show here is the proof that is the simplest to understand, that requires the least amount of mathematical knowledge to understand. So, first off, what is the Pythagorean theorem? Well, if you have a right angle triangle, which means a triangle with a 90-degree angle, and the side of the triangle that doesn't touch the 90-degree angle, which we're calling side C here, it's called the hypotenuse, that the length of that side squared, right, so C squared, is equal to the one of the other lengths squared plus the other length squared. Okay. Now sometimes if you take the square root of both sides, you actually end up with an equation like this: the square root of a squared plus b squared equals c. Sometimes the theorem is presented like this. It's the same equation. We're just taking the square root of both sides here. So for example, if you have a right angle triangle, and let's say the side lengths are 3 and 4, the two sides that touch the right angle, what is side C? What's its length? Well, C squared is equal to A squared plus B squared, where A and B are the two sides that touch the right angle. So that's going to be 3 squared plus 4 squared, which is 9 plus 16, which is 25. So if C squared equals 25, well then C is equal to the square root of 25, which is 5. Right? So the length of side C is 5. Very useful theorem because right angle triangles come in handy a lot for a lot of calculations. You have a right angle situation, you need to know the diagonal. So why is this theorem true? Well, let's take a square. Okay, and we're going to separate each side of that square into two sections. One section we're going to call length A, and the other section we're going to call length B. Okay, and we're going to do that for every side of the square. A and B, A and B, A and B. Okay, and that's going to work because, well, it's a square. Every side is the same length, and that length is A plus B. And then we're going to create 4 triangles by connecting these points that separate the section of the length which is A and the section of the length which is B. So now we have this internal shape here, and we're going to claim that this internal shape is actually a square. And the side lengths, we're going to call it C. Okay, now why is that a square? So first thing we want to show is why are these right angles here? How do we know these are right angles? Well, these triangles here with side lengths A and B, okay, so this is the same size triangle, right? They all have a right angle. They all have side lengths A and B, right? So the hypotenuse must also be the same length, right? Because that hypotenuse, that diagonal, comes from a base of A, right? And a height of B, right? A base of A and a height of B. And the two that are top left and bottom right here, well, if you just rotate them 90 degrees, then again, they'll have a base of A and a height of B, right? And then you have the diagonal connecting those two sides. So we have these 4 triangles that are the same size, which means these hypotenuses of them are all the same length, right? So we're going to call them C. Now, why is this a 90-degree angle? Well, let's say in these triangles, the corner with side B is X and the corner with side A is Y. Okay, and we're gonna put that everywhere here. Right? So we know the 3 angles of a triangle have to add up to 180. So X plus Y plus 90, because the third corner is 90 degrees, that is equal to 180. Which tells us that X plus Y is 180 minus 90, which is 90. Okay, so X plus Y is 90. And if we look at this section right here, we have 4 of those sections, right? So this angle here that we're claiming is 90 degrees, how do we know it's 90 degrees? Well, this is a straight line here, right? So this entire angle has to be 180. Okay? So x plus y plus whatever that corner is has to equal 180. Okay, well we know x plus y is 90. So 90 plus that corner is 180. Well, so that corner has to be 90 as well, because 90 plus 90 is 180. Okay, so we know that this is in fact a square in the middle here with side length c. Okay, and here's what we're going to do next. Okay, let me just copy and paste this so it's easier to see. Okay, we're going to take these corners and we're going to rotate these triangles. Okay, so this triangle here, we're actually going to rotate it to put it there. Okay, so what we're going to end up with is it's going to look like that. Okay, so this side B is going to end up right here, and this side A is going to end up right here. Okay, and then this other triangle, this one here, we're going to rotate it this way. Okay, so this is the shape we're going to end up getting. So this side A is going to end up here, and this side length B is going to end up right here. All right, so the shape that we're going to get is going to end up looking like this. Okay, so we started off with something like that. Okay, A, B, A, B, A, B, A, B, and this is C, 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 and we know it's a square, so we know that middle section that the triangles aren't taking up, that area is equal to C squared. Okay, and after rotating our triangles, as described above, okay, so this triangle we never rotated, right? It stayed put. And this triangle we never rotated. It stayed put, right? But after this rotation, that triangle ends up here. And after this rotation, that triangle ends up here, right? So our empty space is now this, right? This is now our empty space that's not taken up by these triangles. Now, what's the area of that empty space? Well, we know this side length is A, right? This is A right here, okay? And it came from here, right? It came from here, so we know that this is also A, okay? So this section here, that's A squared. And then what about this section right here? Let me just change the color. Okay, well, we know this is B, right? And we know that this is B because it came from here, right? So this section here is B squared, okay? And we know these two sections, these two areas have to be equal to each other because it's the area that the triangles don't take up, okay? So what you have then is C squared equals A squared plus B squared. And that's it. That's why the Pythagorean theorem is what it is. You don't just have to believe it now. Now you know why it's true. So, I hope that helps, and until next time.